we're solving problem 3 from the 2026 AIME 2. Let ABCDE be a non-convex pentagon with internal angles, angle A equals angle E equals 90 degrees, and angle B equals angle D equals 45 degrees. Suppose that DE is less than AB, AE equals 20, BC equals 14 root 2, and points B, C, and D lie on the same side of line AE. Suppose further that AB is an integer with AB is less than 2026 and the area of pentagon ABCDE is an integer multiple of 16. Find the number of possible values of AB. So this is basically most of the information that they gave us with values. We also know AB is less than 2026 and is an integer. So from that we can use coordinates to solve this problem. So we let A be the origin, E be 20, 0, AB have a value of x, therefore B is 0, x, and D is equal to some value, or at some point 20, h, where h is equal to DE. And in this case, we already proved from DE is less than AB, h has to be less than x, and then we also find that angle ABC is equal to 45 degrees. Now what we can do here is we can further utilize these values and these new values that we assigned to help us solve the problem. So with this information, what we can do, because we know BC is equal to 14 root 2, we can set point C into coordinates as well. C has the coordinates of 14, x minus 14. And what this means is that basically angle CDE, angle CDE also has angle 45 degrees, which means angle DE also has 45 degrees. Now, what we can do with that information is we can have a value of D. So D is going to be equal to 20, x minus 8. And we have found h is equal to this x minus 8. So then we have from here DE equals x minus 8. And we have x minus 8 is less than x, giving us x is greater than 8. Now, what we can do is we apply the shoelace theorem. So everything multiplies by 0 except this one term, which gives us 14x minus 112 from the shoelace theorem. Therefore, A is going to be having a value of 20x minus 164. Now, 20x minus 164 simplified with modulo 16 is 4 times x minus 1 mod 16, which means that x is congruent to 1 mod 4. Now, from this we have the value the values for that we want to find. So we have 9, 13, 17, ... all the way to 20, 25. We want to sum all these values together, find how many there are here. So we do 20, 25 minus 9 over 4 plus 1. And this is a formula from arithmetic sequences because this is an arithmetic sequence. This gives us 505 numbers, which is our answer for this problem.